talk about circuits again today. So when you get to Tinkercad, it should look a lot like this. But today, I want to talk about circuits. So I'm going to go click down here at circuits, and here are the lessons that you've already done. But I'm going to create a new circuit because I want to talk today about breadboards and how breadboards are wired and how it all works. To understand that, there's a couple things that you need to know. First is, how do you rename your Tinkercad? If you just come up here and click on it, you can rename it anything you want. So, Breadboard Introduction, that's what I'll name. I hit return or enter, and there it is. Yay, it's just that easy. And I need a breadboard. But before I get into that, you should know that they have these kind of starters. So if you come over here, and if you just leave it at basic, it has pretty much all the stuff that we're ever going to use. But you can go to all, and things get complicated. You can start getting it like a polarized capacitor. We're not going to use that much. But they also here have its starters. If you just want to start and don't want to necessarily throw everything in by yourself, they have some things here that are pre-made that are kind of nice. Like when we get into Arduinos, it might be easiest to just kind of open one of these as your starter. But let's get back to basics. Okay, so I need a breadboard. I could scroll around, or I could just type in bread and click breadboard, and here they are. Now there are huge breadboards or mini breadboards. I'm going to do a small breadboard, and I'm going to bring it out here. And I'm going to hit R on my keyboard a couple times, and that just allows me, oops, sorry, did that. That just allows me to read the numbers. If you look here, you'll see that the breadboard is numbered from 1 to 30, and read the letters, right? There's A through E on this side, then there's this channel, and then there's F through J. And you'll notice that positive is on the left here, positive is also on the left here, negative and negative. Okay, so it's not exactly 180-degree rotational symmetry, but pretty darn close. And what I want to talk about is basics of electronics and then basics of breadboards. So let's start with the basics of electronics. So I'm just going to start building a really simple setup. I'm going to take a coin battery, and I'm going to hit R on my keyboard a couple times so that positive is on the right and negative is on the left. And then I'm going to check out some LEDs. I just want a basic LED. And let's move all this down so that those pop-ups don't necessarily get in the way. And if I see, it tells me positive, and I can see the positive on the battery. This end is the positive. That means electricity flows out here, and then it goes in here. So electricity always leaves the positive because it's negative. It runs out of the positive and wants to go home to its negative side. This is home. So electricity leaves positive, goes negative if it were connected, but it's not connected. If I look at the LED, I see anode. So one of the legs is called an anode, and the other leg is called a cathode. And the nice thing about that is it's alphabetical. A is where it enters. So if I click on the positive and drag it over here and click on anode, a wire forms. And hey, you know what? I'm going to hit number 2 on my keyboard and make it red, because positive is red usually means positive. And if I go from cathode, I click on cathode, and I click down on negative, and I hit the number 1 on my keyboard. I have a positive wire taking the electricity from the positive end into the anode. It flows through the LED, comes out the cathode, and goes down into the negative. And let's see what happens when I hit simulation. Yay, it totally works. And this says, wow, you have triple the amount of electricity going through here than we really like. Just to tell you, you're going to blow out your LED soon. And I say, I totally agree, except this is a simulation and they don't blow out. Yay! But in the real world, we would want to put a resistor in there so that we don't blow out our LED. Now, the question is, does it matter? I don't know. Let's clear these wires out. And what if I go from positive to cathode? Again, hitting number 2 to make it red. And I go from negative to anode. So this is wired backwards. So the red, instead of going into the anode, it goes into the cathode. And the black goes into the anode. So this has electricity flowing in the cathode leg and out the anode leg. Let's see what happens. Not a very bright light, is it? No, because it's wired backwards. Okay, so it turns out that direction matters for LEDs. They have to go from the positive to the anode, hitting number 2 to make it red, from the negative into out of the cathode into the negative, hitting number 1 to make it black, and now it works perfectly. Yay, even though I'm going to blow it out. Okay, so that matters because breadboards. There's a positive and a negative channel, so if I shrink this down just a little bit so we can see things, let's pull this up, and I'm going to grab that guy and put it over, and the positive and negative are positives on the left, negatives on the right. My battery's backwards, so I'm just going to highlight the battery, hit R on my keyboard, and then that's going to make this nice and easy. I connect the positive to any spot along this. You'll notice as I highlight it, they all become highlighted because underneath these holes is a wire that just connects all those holes. So if I have a wire coming out this end here, it's actually connected to the battery underneath. And that's what a breadboard does, is it gives you really easy connections. All of these are connected. So if I, let's say, put it here with this wire, the electricity flows out of the battery, up this wire, underneath all these holes, out these holes, and powers this spot right here. And this spot is G4. So G4 now has power flowing into it because it runs underneath here. So there's a whole bunch of wires underneath the breadboard. I actually don't need that. Same thing with the negative. So I take the negative, I put it there, I hit number 1 to make it black, and now electricity from any of these holes will flow back into the battery because they're all connected underneath. Now, let's say I take my LED and I just jam it in here. By the way, these are connected the same way, but this side of the breadboard does not connect to this side. That's why there's a trough right here. There's a little ridge right here. No wires connect there. Now, I could connect them myself because if I take, let's say, a wire from here to here, hitting number 2 to make it red, now electricity flows out of the battery, up all these holes, across here, and then down all these holes. And it's very normal when you first get a breadboard to do this, to connect the positive on one side to the positive on the other, the negative on one side to the negative of the other. Now, this hole right here gets power by being connected underneath, coming across this wire, being connected underneath, and here it is. And this one returns home by being connected underneath, coming through this black wire at the top, and then being connected underneath. And I'll show you that in just a second. So here we have an LED. Now these power strips go up and down. The ones in the middle go sideways. So let's zoom in a little bit so we can see that. Notice how if I highlight any of these, they all light up, and that's because the wires here, where the numbers are, go sideways. So here, if I were to connect a wire, it would actually connect both of these. And here's what I mean. Well, let's connect some power to it. I hit number 2, okay. And so the power will come up underneath here, connect here, go into the anode, But the problem is the cathode's there too. So even if I take this and connect it out here to the negative, this would look like a working circuit. But if I hit start simulation, nothing happens. And the reason why is because the electricity comes in here, connects underneath, and then says, wait, why would I bother going through an LED if I can just skip underneath and go straight home? Electricity is intensely lazy, just like you. So since all of these are connected underneath, just as all of these are connected underneath, since all of these are connected underneath, why would the electricity go into an LED, drop off some energy here to light it up, come back down, and then go out? It wouldn't. It would come in here, follow this wire, skip underneath the LED, and then go straight home. And that's what happens. Notice how the light doesn't turn on. But what if I rotate it? So I hit R on my keyboard, and let's move this down so that I can see a little bit better. I hit R on my keyboard. Notice the anode and the electricity is connected, so it's going to come up here underneath, come through here, go into the anode just as I like, have to pass through the LED because these are not connected. This line and that line are not connected. Each number is its own separate wiring. So the electricity has to go through the LED to come here, and then if I connect this back to away home, then it has to go through the LED. Again, it comes up here. This wire connects it to this entire line. It goes into the anode, comes out the cathode. Underneath, it connects to this wire, which connects it here, and then underneath it goes home. So that's how breadboards are wired. Now, is there a way to make this not work? And the answer is yeah. What if I just do this? Now, electricity, when it comes here to this very spot, it can choose which route to go. One is continue on up here, go through the anode, out the cathode, back here and out, or it can go here, turn around immediately and go home. I wonder which lazy electricity would do. Oh, the light's not lighting up because it's taking a shortcut. Again, teenagers are lazy. And here's the real deal. What if I do it over here? Oops. That was ugly. What if I do it over here? Do you think the light will light up? Well, if I remember correctly, electricity comes in under here, and here it has to make its decision. Does it go through the LED and go home, or does it continue up here, take this wire over, come down here, take a little shortcut, come back up here, take this wire over, and go down and go home? And it says, the electricity should say, why would I go through an LED where I have to drop off a bunch of my energy to light it up when I can just go through wires, zoom, 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 and go straight home? And if I click on Start Simulation, nothing lights up because there's a hidden shortcut right here. Right here, the electricity can go from coming in to going out without having to power anything. And that's what it will choose. But if I break the shortcut and the only way home now is through this LED, then when I click Start Simulation, it'll power up. So the 3 things I wanted you to know. 1, electricity is intensely lazy. It will take the shortest path. A lot of times your circuits won't work because there is, like over here, a hidden shortcut. And you don't realize it, and this doesn't light up because why would electricity go through here when it can take a hidden shortcut? So make sure that you don't have hidden shortcuts. 2 is that the power lines go vertically when in this orientation, and the number lines go this way, go horizontally in this orientation. And it's very normal to just power both up, by the way, and that electricity does not pass through here. Oh, I didn't show that very well. Let me show that now. If I take this and put it over here, now it's plugged in on the other side of the trough. I hit start simulation, it doesn't light up. And the reason why is because these are not connected to these. But if I bring it back onto the same side as the trough and hit start simulation, it lights up. Okay, there's your introduction to breadboards, how they're wired underneath and how to use them. Now, I wish you luck with the rest of circuitry. Good luck.